On July 24th, the Sun's southeastern quadrant suddenly became highly active. A long magnetic filament suspended above the solar surface began to destabilize after days of magnetic stress. As the magnetic field snapped and reconnected, the filament erupted violently into space. Billions of tons of superheated plasma and twisted magnetic fields were launched outward, marking the birth of a coronal mass ejection, or CME. The expanding CME raced through interplanetary space at hundreds of kilometers per second, carrying a giant magnetic bubble across the solar system. Space weather observatories immediately began tracking its speed, direction, and magnetic structure to determine whether Earth lay in its path. The eruption also accelerated energetic charged particles along the Sun's magnetic field lines, producing an S1 level solar radiation storm. This minor storm can briefly affect high-frequency radio communications over Earth's sunlit hemisphere and increase radiation exposure for satellites and spacecraft. The event was associated with a Class C solar flare, the weakest major X-ray flare category, producing X-ray intensities very less. Although relatively small, the flare supplied the energy needed to trigger the filament eruption and launch the CME. Protected by Earth's magnetosphere, most of these charged particles are deflected into space,